Hello everyone. Welcome to Infinity Learn by Sri Chaitanya. So in today's session, I'll discuss weekend test AIIMS physics paper. So let's start with question number 1. A hollow sphere is held suspended. Sand is now poured into it in stages. The center of mass of the sphere with the sand. What will happen to the center of mass if we pour sand continuously into this hollow sphere? So initially the level of the sand will increase, right? So center of mass will rise, and after center of mass will fall, and after certain stage, after it is completely uniform, the center of mass will be fixed at the center, right? So it will fall, then rise to the original position. So correct answer will be option 3. Question number 2. Two spheres of mass m and m are situated in air and gravitational force between them is F. Now the space around the mass is now filled with a liquid of specific gravity 3. The gravitational force now will be. So gravitational force is independent of the medium between the particles, right? So initially if it is F, finally it will be F. So correct answer is option number 2. Question number 3. An athlete completes one round of a circular track of radius r in 40 seconds. What will be his displacement at the end of 3 minutes? So 3 minutes is 3 into 60 seconds, which is equals to 180 seconds, right? So in 160 seconds, it will complete 4 rounds. Fine. So up to 160 seconds, it will complete 4 rounds and it will be again at its initial position. But now we have 20 seconds extra. So in the next 20 seconds, it will complete half of the round and it will be here. So initial and final position difference is nothing but the displacement, which is equals to diameter of the circle, which is equals to 2r. So correct answer is option 2. Question number 4. The amplitude of the particle executing SHM with the frequency is 60 Hertz is 0.01 meter. The maximum value of acceleration of the particle is, so A max is omega square A, right? Omega square is 2 pi f whole square into A. So it will be 2 pi into 60 whole square into A is 0.01 and it will give you 144 pi square meter per second square, which is option number 2. Question number 5. A uniform wire of length L is bent in the form of a circle like this. The shift in its center of mass is. So this is the initial position of center of mass, right? Now it will be here at the center of this symmetrical structure, right? So this shift is equal to radius, right? But radius is not given, but we know that the total circumference of the circle should be L, which is equals to 2 pi r. So r will be L upon 2 pi, which is equals to option 3. Question number 6. Choose the wrong statement. At the center of mass, mass may or may not be present. That is true, like donut. In non-uniform gravitational field, center of mass does not coincide with the center of gravity. That is true. Center of mass is independent of acceleration due to gravity, but center of gravity depends on the acceleration due to gravity. True. Location of center of mass of a system depends on the frame of reference. No, it does not depend on the frame of reference, right? So wrong statement is option 4. Question number 7. The engine of a train passes an electric pole with speed u and the last compartment of the train crosses the same pole with speed v. Then the velocity of the midpoint of the train passes the pole is. Okay, so it is same as that of this question. Ki we have a complete L length, है ना? And initially it is u and finally velocity is v. What should be the velocity of the midpoint? So it is v dash, right? So between u and v dash, the length of the train passed is L by 2, and v dash to v, the length of the train passed is L by 2. Acceleration is a. So for the first half you can apply v dash square is equals to u square plus 2a L by 2, and for the second half you can apply v square is equals to v dash square plus 2a L by 2, है ना? V is equal, v is final velocity, u is initial velocity, right? So when you add these two equations, you'll get v, you can what you can do is do not add this to equations, subtract this to equation. So v dash square minus v square is equals to u square minus v dash square, right? So v dash square 2 times will be v square plus u square. So v dash square will be v square plus u square by 2 and v dash will be v square plus u square by 2 whole root, which is option 4. Question number 8. The radii of two planets are R1 and R2 and their densities respectively are ρ1 and ρ2. The ratio of acceleration due to gravity at their surfaces. So acceleration due to gravity in terms of density is 4 by 3 pi rho g, small g nahi, capital G, right? Capital G into R. Right? So G is directly proportional to rho into R. Fine. G is directly proportional to rho into R. So G1 is to G2 will be rho1 R1 is to rho2 R2. Fine. So correct answer will be option 4. Question number 9. The restoring force of SHM is maximum. So restoring force is minus AX and it will be maximum when X is maximum. X is maximum when the displacement is maximum. So correct answer is option 2. Question number 10. The displacement time graph of two particles A and B are straight lines making angles of 30° and 45° respectively with the time axis. If the velocity of A is VA and that of B is VB, then the value of VA upon VB. So, slope of displacement time graph will give you velocity. Slope is what? Tan theta. So, VA upon VB will be tan 30° divided by tan 45°. Tan 30° is 1 by root 3 divided by tan 45 is 1. So it is 1 by root 3, which is option 2. Question number 11. Four particles of masses m1, m2, m3 and m4 are placed at the vertices ABCD respectively of a square as shown in the figure. The center of mass of the system will lie on diagonal AC if. So this is diagonal AC. And center of mass of the system should lie on this line. That means if you look at this diagonal BD, if center of mass should lie at the symmetry line, that means the mass distribution about AC should be symmetrical. That means M2 should be equal to M4. Then and then only center of mass will lie on AC. Symmetrical distribution should be there. So correct answer will be option 1. Question number 12. An object of mass m is moving in a uniform circular motion in the xy plane. The circle has radius r and the object is moving around the circle with speed v. The motion is projected onto the x-axis where it appears as simple harmonic motion according to xt is equals to r cos omega t plus phi, where omega is equal to, so omega is equals to v upon r, which is option 1. Question number 13. A particle is moving along x-axis under the action of variable force which is providing position varying acceleration described by the equation 3x minus 4 at t is equals to 0, x is given as 4 by 3 meter and v is given as 0. Find the velocity and position of the particle at t is equals to 5 seconds. So, when you put the value of x in acceleration equation, it will be 3 into 4 by 3 minus 4, which is equals to 0 meter per second square. So, at t is equals to 0, acceleration of the particle is 0, velocity of the particle is 0. So, particle is at rest. So, after 5 seconds, its velocity will be 0 and position will be equal to the initial position, which is 4 by 3 meter. So, correct answer is option 3. 0 meter per second velocity and 4 by 3 meter is the position at t is equals to 5 seconds. Question number 14. 100 balls of different masses are thrown at different instants up against gravity. While all balls are in air, the center of mass of the system of balls has an acceleration. So, ACM will be m1 a1 plus m2 a2 so on divided by m1 plus m2 plus so on, right? So a1 plus a1 is equals to a2 is equals to a3 is equals to g. right? All the balls are performing motion under gravity. So you can write a1 is equals to a2 is equals to a3 and so on is equals to g. So you can take g common, so it will be m1 plus m2 and so on divided by m1 plus m2 and so on, right? So this will cancel this term. So acceleration of center of mass will be equal to g, which is equals to option 2. Question number 15. Three particles, each of 1 kilogram, are placed at corners of a right angle triangle AOB, where O is the origin, OA is the x-axis, and OB is along y-axis. Right, and OA is equals to OB is equals to 1 meter. We need to find the position vector of the center of mass. So this will be 1 comma 0 and this will be 0 comma 1, right, and this will be 0 comma 0. And we have three particle, 1 kilogram, 1 kilogram and 1 kilogram over here. So you can find XCM as M1 X1 plus M2 X2 plus M3 X3 divided by M1 plus M2 plus M3, which is 1 by 3 meter. YCM is M1 Y1 1 into 0 plus M2 Y2 1 into 0 plus M3 by 3 1 into 1 divided by M1 plus M2 plus M3, which is 1 by 3 meter. Right, so we have XCM, YCM. So let's find position vector. So it will be 1 by 3 I cap plus 1 by 3 J cap. So it is I plus J by 3, which is option 1. Question number 16. If m is the mass of system and ACM vector be the acceleration of its center of mass, then correct equation is. So MACM is equals to net external force on the system. So correct equation will be option 3. Question number 17. Two bodies of masses 10 power 2 kilogram and 10 power 3 kilogram are lying 1 meter apart. Okay. The gravitational potential at the midpoint of the line joining them. So this will be 1 by 2 meter and this will be 1 by 2 meter. So because of this 10 power 2 kilogram, gravitational potential will be minus g 10 power 2 divided by r. And because of this 10 power 3 kilogram, gravitational potential at this point will be minus g 10 power 3 divided by r. Right, minus gm upon r. You can add this two gravitational potentials to get the total value of gravitational potential at midpoint P, right, and this will be minus 1.47 into 10 power minus 7 joule per kilogram. Question number 18. A body is dropped from a height of 40 meter. 40 meter is the total height and it is dropped. That means initial velocity is 0. After it crosses half of the distance, that is 20 meter, the acceleration due to gravity ceases to act. So after this point, g will become 0. So particle will perform a uniform motion. Okay, because there is no acceleration, so particle's velocity will be constant. You need to find the body will hit the ground with velocity. With what velocity, right? So velocity at this point will be equal to velocity at the ground, because after this point motion will be uniform, right? So let's find velocity after 20 meter. So it will be v square is equals to u square plus 2as. V square is the final velocity at this point. U square is 0 plus 2. A will be equal to g, which is 10, and displacement is 20 meter. So it is 400. So V will be 20 meter per second. So after crossing this 20 meter mark, body will move with 20 meter per second, which is equals to option 3. Question number 19. A spacecraft of mass m and moving with velocity v suddenly breaks into two pieces. After the explosion, one of the mass m becomes stationary. What is the velocity of other part of the craft? So remaining mass will be m minus m, and let's say its velocity is v dash. So let's conserve the momentum. Initial momentum mv is equals to final momentum m minus m into v dash. So v dash will be mv divided by m minus m, which is equals to option 2. Question number 20. The escape velocity of a planet having mass 6 times and radius 2 times as that of the Earth is. So let's say escape velocity on the Earth is under root 2 gm upon r. Right, so escape velocity on the planet is ve dash, which is equal to under root 2 g m is 6m divided by r is 2r. So it will be under root 3 times 2 gm upon r. But under root 2 gm upon r is the escape velocity on the surface of the earth. So it is ve dash is equals to under root 3 times ve, which is equal to option 4. Question number 21. The motion of a ball bouncing between two rigid balls is, it is what? Periodic motion. Question number 22. B1, B2 and B3 are three balloons ascending with velocities v, 2v and 3v. So one balloon is with velocity v, other one is with 2v and third one is with velocity 3v. If the bomb is dropped from each balloon when they are at the same height, then which of the following statement is correct? So if you drop any object from the moving object, object will gain the velocity of the moving object. So initially, bomb's velocity will be v, 2v and 3v in the upward direction. At the highest point of its motion, velocity will be 0. So time taken to go up. Let's calculate. It will come back like this. It will come back like this and it will come back like this. Okay. So time taken to go up. At the highest point, velocity will be 0 for each and every bomb, right? So acceleration will be minus g downwards. So we can apply this equation. V square is equals to u square plus 2as. V square is 0. U square is v square plus 2, which is minus g. A is minus 2g into s. So you can see that s is v square upon 2g. Fine. Okay. But we need to find the time, right? So let's find time. So time is, you can use this equation. V is equals to u plus at. V is 0, u is u, and it is minus gt is equals to 0. So t is equals to u upon g, right? So if initial velocity of the bomb is more, time taken to go up will be more and it will take more time to come down, right? So for the lesser velocity, time taken to go up and come down will be less. So the bomb with less initial velocity will strike the ground first. So it should be bomb B1, right? So B1 from bomb from B1 reaches the ground first, which is option 1. Question number 23. A force of 25 Newton act on a system of three particles of mass 2, 4 and 5 kilogram, producing 2 meter per second square in 2 kilogram, 4 meter per second square in 4 kilogram in the direction of force, then acceleration and produced in 5 kilogram masses. So this total force is equals to total mass into acceleration of individual particles, right? So it is 2 into 2 plus 4 into 4 plus, let's say, acceleration of phi is a. So it is 25 is equals to 4 plus 16 plus phi a. So phi a will be phi and a will be 1 meter per second square, which is option 1. Question number 24. A planet moves in a circular path. It describes equal angles about the center in equal intervals of time. Which of the following statements about the velocity of the planet is true? So velocity of the planet is changing continuously. Why? Because the direction of the velocity of the planet will change. So it is not constant. Only magnitude will be constant because it is describing equal angles in equal interval of time about the center, right? So velocity is constant, not constant, but magnitude is constant and direction is changing. So correct answer is option 4. Question number 25. The SHM equation is y is equals to a sine 2 pi nt plus alpha. Then its phase at time t is. So this is complete phase, which is 2 pi nt plus alpha. So correct answer is option 4. Question number 26. Which of the following quantities does not depend upon the orbital radius of the satellite? So t square is directly proportional to r cube. So t square is equals to k r cube. So t square upon r cube is equals to constant, which does not depend on the radius of the satellite. So our correct answer is option 3. Question number 27. Two particles, one with constant velocity 50 meter per second and other with uniform acceleration 10 meter per second square, start moving simultaneously from the same place in the same direction. They will be at a distance 125 meter from each other after what time? So we have one particle which is moving with 50 meter per second. Other particle is moving with the initial velocity 0 but acceleration 10 meter per second square. So we need to find the time at which the separation between these two particles will be 125 meter. So let's say after certain time this particle is over here and this particle is over here. The separation is 125 meter. Fine. So, time taken to complete this much journey is t. So, for the first particle, distance covered is s1, which is 50t, and for the second particle, distance covered is s2, which is half a t square, which is equals to 5t square. Right? Now, s2 minus s1 should be 125. Matlab 5t square minus 50t should be 125. If you solve this quadratic equation, you will get the value of time as 5 into 1 plus root 2 seconds. Question number 28. A block moving in air explodes into two parts. Then just after explosion, momentum of the system will be conserved, right? So correct answer will be option 1. The total momentum of two parts must be same to the momentum of the block before explosion. Question number 29. A planet moving along an elliptical orbit is close to the sun at a distance r1 and farthest away at a distance r2 if v1 and v2 are the linear velocities at these points respectively, then v1 upon v2 is. So you can conserve the momentum m v1 upon v1 r1 is equals to m v2 r2. So v1 upon v2 will be equal to r2 upon r1, which is equals to option 1. Question number 30. The equation of motion of a particle executing SHM is A plus 16 pi square x is equals to 0. So you can write A is equals to minus 16 pi square into x. In this equation, A is the linear acceleration in meter per second square of the particle at a displacement x in meter. The time period in simple harmonic motion is. So basically this is A is equals to minus omega square x. So omega square is equals to 16 pi square. So omega will be 4 pi, which is equals to 2 pi by t. Omega is 2 pi by t, which is equals to 4 pi in this particular question. So time period will be 1 by 2 seconds. So correct answer is option 1. Question number 31. A bus starts moving with acceleration 2 meter per second square. A cyclist 96 meter behind the bus starts simultaneously towards the bus at 20 meter per second. After what time will he be able to overtake the bus? So let's say this is the bus point and this is the cyclist. The separation is 96 meter. Bus starts with 2 meter per second square, and let's say after certain time t, bus is over here, and after certain time t, cyclist is also over here. So this is the point where the cyclist will overtake the bus, right? So this is the distance covered by the bus s1, which is equal to half a t square, which is equals to t square. And S2 is the total distance covered by the cyclist, which is equal to 96 plus S1, and that is equals to it is 20 into T, because this I'm assuming that they will cross each other after some time T, right? So 96 plus t square should be 20t. After solving this quadratic equation, we'll get the value of t as 8 seconds. Question number 32. Two ice skaters A and B approach each other at right angles. So A has mass 30 kg and velocity 1 meter per second. And skater B has mass 20 kg and velocity 2 meter per second. So let's say 30 kg is moving with 1 meter per second and 20 kg is moving with 2 meter per second. They meet and cling together. Then find the final velocity of the couple. Right? So initial momentum of the system is 30 I cap plus 40 j cap. So its magnitude will be under root of 30 square plus 40 square, which is equals to 50. Final momentum magnitude should be equal. Let's say speed of the couple is v. So final momentum is equals to total mass of the couple 50 into v. So v will be 1 meter per second. So correct answer is option 4. Question number 33. Two satellites A and B go round a planet in circular orbits having radii 4r and r respectively. A is moving in a radii 4r, B is moving in radii r. If the speed of satellite A is 3v, then speed of B is, let's say it is v dash. So 3v is equal to under root gm upon 4r. So you can write under root gm upon r 1 by 2 times as 3v. So this will give you under root gm upon r as 6v, right? Now let's find orbital speed of the satellite b v dash, which will be under root gm upon r. But under root gm upon r is 6v using first situation. So speed of the second satellite will be 6v, which is option 1. Question number 34. The displacement of two particles executing SHM are represented by equations. y1 is equals to 2 sine 10t plus theta and y2 is equals to 3 cos 10t. Right. So the phase difference between the velocity of these two particles is. So you can write y2 as 3 sine pi by 2 plus 10t. Right. So phase difference will be alpha 1 minus alpha 2. So it is 10t plus theta minus pi by 2 plus 10t, which is equal to theta minus pi by 2. So phase difference will be option 3. Question number 35. A bullet emerges from a barrel of length 1.2 meter with a speed 640 meter per second. Initial velocity is 0. Assuming constant acceleration, the approximate time it spends in the barrel after the gun is fired is. Okay. So let's find the acceleration first. So v square is equals to u square plus 2as. V square is 640 square is equals to 0 square plus 2a, s is 1.2. So a will be 640 square divided by 2.4, right? Now let's apply first equation of motion. V is equals to u plus at. V is 640 is equals to u plus a, which is 640 square divided by 2.4 into t. So time will be 640 into 2.4 divided by 640 square, and it will be equal to 40 millisecond, 4 milliseconds, sorry. Next is question number 36. Mr. Ashwar drives his car at uniform speed from the bottom of a mountain to the top in 30 minutes. From this point to this point, he takes 30 minutes. At the beginning, the speedometer of his car shows 6225 km, while on reaching the top, it reaches 6285 km. The distance covered is. So distance covered will be equal to difference in the readings, which is equals to 60 km. So distance will be 60 km. Question number 37. Three identical spheres, each of mass 1 kg, are kept as shown in figure, touching each other with their centers on a straight line. If the centers are marked as P, Q, R respectively, the distance of the sphere, center of mass of the system from P is. So P is 0, 0. This distance is PQ, and this complete distance from the origin is PR, right? Identical, that means masses are equal. So center of mass will be m1x1, which is m into 0 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. So you can take m common, so it will be pq plus pr divided by 3, which is option 2. Question number 38. Mass m is divided into two equal parts, xm and 1 minus x into m. For a given separation, the value of x for which the gravitational attraction between the two pieces becomes maximum is. So gravitational attraction will be g m1 m2 divided by r square, and it should be maximum. So for maximum, this df by dx should be 0, right? So basically this g m square upon r square into x minus x square differentiation with respect to x should be 0. So let's differentiate this quantity. So it is gm square upon r square. Differentiation of x is 1 minus differentiation of x square is 2x and it should be 0. That means 1 minus 2x should be 0. So x is 1 by 2. So correct answer is option 2. Question number 39. Two identical particles move towards each other with velocity 2v and v respectively. The velocity of center of masses. So it is m1 v1 vector plus m2 v2 vector divided by m1 plus m2. So it is m into 2v plus m into minus v because it is opposite to 2v divided by m1 plus m2 2m. So this will be m by mv by 2m which is equals to v by 2. So correct answer is option 3. Question number 40. A uniform meter rod is bent into L shape at midpoint with the bent arms at 90 degree to each other like this. So this will be half meter, this will be half meter. The distance of center of mass from the bent point is. So let's say this part has mass m, this part will be mass m, again equal halves. The center of mass of the first half lies at the center, so it will be at a distance 1 by 4. So it is 0 comma 1 by 4, and this center of mass of the second horizontal rod will be 1 by 4 comma 0, right? So let's find xcm. So it is m1 x1 which is m into 1 by 4 plus m2 x2 divided by m1 plus m2 which is 1 by 8 meter. Similarly, YCM will be M1 by 1 plus M2 by 2 divided by M1 plus M2. So it is again 1 by 8 meter, right? So total distance from the origin will be under root of 1 by 8 square plus 1 by 8 square which is equals to 1 by 64 plus 1 by 64, that is 2 by 64 square root which is equals to 1 upon 4 root 2 meter. So correct answer is option 1. Question number 41. Two persons 60 kilogram, 80 kilogram are sitting at the end of a boat of mass 60 kilogram. So let's say this is 60, 80 kilogram person and boat is of mass 60 kilogram. So let's take 60 kilogram as origin, right? So this is the midpoint of the boat. So center of mass of the boat will be at the midpoint which is at a distance 2 meter from the 60 kilogram. Right, so for this one coordinate will be 2 comma 0, for this one coordinate will be 4 comma 0 and for this one it is 0 comma 0. So initial location of center of mass is xcm of center of mass is m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3 which is 200. So it will be 11 by 5 meter. Now the 60 and 80 kilogram are interchanging the position. So we need to find the correct statement. Okay. Right. So it will be 80 will be here, 60 will be here and center of mass of the boat will be here at 2 comma 0. This will become now 4 comma 0 and this will become 0 comma 0. So x dash will be m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3 which is equals to 9 by 5 meter. So there's a shift in center of mass which is 9 by 11 by 5 minus 9 by 5 which is 2 by 5 meter which is equals to 0.4 meter. Okay. So this shift in center of mass, but center of mass cannot move, right? So both should shift by 0.4 meter which is equals to option 1. Question number 42. A tank filled with water is connected to another empty tank lying in the right side of the first tank. So we have a water filled tank and we have empty tank over here. Okay. Now these two are connected by some, source. So until the level of the water in the tanks becomes same, center of mass of water shift down at constant rate. Okay. Center of mass of water shifts down and rate of change of shift of center of mass decreases gradually and becomes 0. Yes, because water is flowing from this tank to this tank. So what will happen? Initially, the center of mass will shift down because the level of the water is decreasing, right? And after some time, after some time the level of the water will become same and there will be no flow of water, so it will become, the shift in center of mass will become 0, right? The center of mass shift towards right as well down, right? Yes, the mass is flowing towards right, so center of mass will also shift towards right. So correct answer is option B and C are correct, which is option 2. Next question is 43. The body of mass m starts falling at a point 2r above the surface of the earth. So this distance is 2r and this is mass m. So its distance from the center of the surface earth will be 3r. Gravitational potential energy at this point will be minus gmm divided by 3r. Now we have another point over here, right? Its kinetic energy when it has fallen to a point r above the earth's surface is. So at this point gravitational potential energy will be minus gmm divided by 2r, right? So the change in potential energy, or you can say that loss in potential energy, will give you gain in kinetic energy. So loss in potential energy will be uh, G minus GMM divided by 3R minus of minus GMM divided by 2R, and that is equals to gain in kinetic energy, which is equal to 1 by 6 GMM upon R, which is option 3. Question number 44. A body just dropped from a tower explodes into two pieces of equal mass in midair. Which of the following is not possible? One part reaches the ground earlier than other. Yeah, it's possible. Each part will follow parabolic path. Possible. Only one part will follow parabolic path. Not possible. Right? If one particle is going in this direction and other particle is going in this direction, then and then only momentum is conserved, right, along x-axis. So both of these two particles will follow a parabolic path. Both parts move along a vertical line. That is also possible, right? So correct answer is option 3. Question number 45. A particle moves half distance with V naught. So let's say total distance is 2s. So half distance of the particle is completed by V naught. The remaining is covered with V1 for the first half time. So let's say time taken in this next S is 2t. So for the first t, the speed is V1, and for the next t time, speed is V2. Right, so v1t plus v2t should be equal to s, so t is equals to s upon v1 plus v2. So time taken in completing the second half is 2t, so it is 2s upon v1 plus v2, and time taken in the first half will be s upon v naught. So average speed of the particle is equal to total distance upon total time, which is t1 plus 2t. So it is s upon v naught plus 2s upon v1 plus v2, and it will be option 2, 2v naught into v1 plus v2 divided by v1 plus v2 plus 2v naught. Question number 46. The distance between the centers of carbon and oxygen atoms in carbon monoxide gas molecule is 1.4 into 10 power minus 10 meter. The distance of center of mass of the molecule relative to carbon atom is. Okay, so let's say this is the center of mass. Okay, and let's say this distance is R1. So we know that R1 is M2 into R divided by M1 plus M2, right? So M2 is the mass of the oxygen atom, which is equal to 16. R is total separation, and M1 plus M2 will be 16 plus 12. So it will give you 0.8 into 10 power minus 10 meter. Question number 47. The acceleration a of a particle starting from rest varies with time according to relation. A is equals to alpha t plus beta, which is equals to dv by dt. The velocity of the particle after time t will be. So dv can be written as alpha t plus beta into dt. So let's integrate this one. At t is equals to 0, velocity was 0. At t is equals to t, let's say velocity is v. So integration of dv will be v minus 0, and that is equals to alpha t square by 2 plus beta t. So v will be alpha t square by 2 plus beta t, and that is the velocity at time t, which is option 4. Question number 48. A uniform disk of radius r is put over another uniform disk of radius 2r of same thickness and density. So this distance is 2r. The peripheries of two disks touch each other. Okay, so this is the periphery of the first disk, and these two are touching each other, right? And this is the center of the another disk, and this is radius r by 2, radius r. Okay, radius r. The position of their center of masses. So let's consider this as 0 comma 0, right? Okay, and this is x-axis and this is y-axis. Fine. So center of mass of the first disk is 0 comma 0, and center of mass of the second disk will be r comma 0, right? Now you can also apply XCM as a1 x1 plus a2 x2 divided by a1 plus a2. So a1 is the area of the first disk, which is pi into 2r whole square into x1 is 0, plus a2 which is pi r square into x2 is r divided by a1 plus a2, which is 5 pi r square. So center of mass will be r by 5 distance from the center of the first disk, right? Which is option 2. Question number 49. Which of the following expressions of the force that corresponds to simple harmonic motion along a straight line where x is the displacement and ABC are positive constant? So for SHM, F is equals to, F should be directly proportional to minus x. So F is equals to minus Bx is the appropriate representation of force in simple harmonic motion, which is option 3. Question number 50. The speed v of a car moving on a straight road changes according to equation v square is equals to a plus bx, where a and b are positive constants. The magnitude of acceleration in the course of such motion is, so we know that a is equals to v dv by dx. So let's differentiate this equation. So it will be 2v dv by dx is equals to 0 plus b. So v dv by dx will be b by 2, which is equals to acceleration of the particle, right? So b by 2 is a constant quantity, so acceleration of the motion is constant, which is option 3. So thank you so much everyone, and do subscribe to our channel. Take care everyone. Bye.